Let me introduce the first very important concept, the concept of signals. Usually, we have got a process, as we could see in the first introductory block of this lecture series. So we have got a process, and we would like to get some information about the behavior of this process. So we need some data. So we need some measured data. And this measured data can be performed by an appropriate sensor. Every physical quantity of a process can be measured by an appropriate sensor. So we can select an appropriate sensor to measure something. And the information which is important for us from the process behavior can be represented by the signal. What is the signal? The signal is the value or the change of the physical quantity, and this is the value or the change of the quantity is the information for us. For example, if we have got a vehicle which is moving and we need the speed and the position of the vehicle. So the information is the speed and the position, because in this case we know where the vehicle is and what the speed of the vehicle is. But we have to use some time functions for that information, and it will be x of t for the position and v of t for the speed of the vehicle, and this is the signal. So the signal is a kind of time function. The information is the speed, but this information is represented by the time function v of t. The information is the position of the vehicle, but it is represented by the time function x of t. Okay? This is the difference between the information and the signal. And the signal is a time function. So many cases, if we say it is a signal, we mean it is a time function. Or if we say it is a time function, we mean that it is a signal. So we can use signal and time function for the same situation. Another important example is we have got a bottle of beer, and we are interested in the temperature of that beer because this is the information of that problem. And this temperature can be represented by the time function of the temperature, capital T of T. Or we have got an electric circuit, for example, and we would like to know the power dissipated from that electric circuit. This is the information for us, what the dissipated power is. But the signal is represented, this information is P of T. Of course, there are many other examples for these, but I think these three typical examples can get closer what the information is from a problem and what the signal is. So from these, I think it is important to remember that the signal is a time function, and this time function carries the information from a process.